Hi students, today we're going to continue with chapter 5, water and solution, and the subtopic is 5.2 solution and rate of solubility. I hope all of you are fine and safe at home. Okay, let's continue. Okay, first of all we need to understand three definitions: a solute, a solvent, and a mixture of both, a solution. A solute is a substance that dissolves in a solvent. A solvent is a liquid used to dissolve a substance. And the mixture of the solute and the solvent, we call it as a solution. So I repeat again, when you take salt or sugar, the salt or sugar is a substance called solute. As we dissolve them in water, water is called a solvent, and the mixture of both will become a solution. If you look at it here, if you mix sugar to water, you get a sugar solution. So we have solute, solvent, and a solution. If you look at it again, solute is a substance that can dissolve in a liquid. So solute originally will be a solid that will dissolve in a liquid. A solvent will be a liquid that can dissolve a substance. And the mixture of a solute and a solvent will form a solution. Alright, so we have a solution, a mixture of a solvent and a solute. Then once the solute dissolve in a solvent, we get a solution. And we can see here, if let's say the amount of the solute increases, concentration is increasing. I repeat again, as the amount of the solute increases, the concentration of the solution will increase. So please observe, concentration of a solution increases when the amount of the solute increases. Okay, next. Again, see here, we have three types of solutions. A dilute solution, a solution when the amount of the solute is less. A concentrated solution when the amount of a solute is very big in a solvent. So what will happen once a concentrated solution is formed? We can't dissolve more of a solute, maybe a very less amount of a solute can dissolve, because most of the solute dissolved. So concentrated solution will have more amount of solute than the solvent. Then finally we have a saturated solution. What is a saturated solution? In a saturated solution, we are not able to dissolve any more amount of solute. Cannot really. And all the amount of solute is maximum. If you keep on adding solute in a saturated solution, the excess solute will form a precipitate. So a saturated solution is a solution where you can't add any more amount of solute. Cannot really. So we have dilute solution, less amount of solute, concentrated, more amount of solute, and saturated, that's it, excess. If you put more, it will form a precipitate. Saturated, you are not able to add more amount of solute. And then we have a solution and a suspension. What is the difference between a solution and suspension? Number one, a solution appears clear and transparent. It will be very clear and transparent. But when you have a suspension, it appears cloudy. You can see the precipitate, you can see the suspension there. Suspension will settle if left undisturbed, but the solution will stay uniform. It will stay uniform. And the next one to understand here is solubility. What is solubility? Solubility is the maximum amount of a solvent in gram that can dissolve in 100 milliliter of a solvent at a specific temperature. If you see this example, 90 gram of potassium will dissolve in 100 milliliter of water at a fixed 50 degrees Celsius. So solubility of potassium nitrate is 90 gram for every 100 milliliter of water at 50 degrees Celsius. So solubility of potassium nitrate is 90 gram for every 100 milliliter of water at 50 degrees Celsius. So what is solubility? The maximum amount of a solute in gram that can dissolve in 100 milliliter of a solvent at a specific temperature. So I repeat again, if you see this example, what is the solubility of potassium nitrate? 90 gram for 100 milliliter of water at 50 degrees Celsius. And you will get a solution, saturated potassium nitrate solution. And then we see here, when substances are dissolving, what is the rate or what is the factors that affect the rate of solubility? So it's the temperature of the solvent, rate of stirring, and size of soluble. Very simple. When you increase the temperature, the solute or the substance will dissolve easily, very fast. If you increase the rate of stirring, you move it faster, you stir faster, rate of solubility will increase. And the third factor is the size of solute. When your solute substance is very tiny and small in a powdered form, they will dissolve faster. So the factors affecting the rate of solubility are temperature. The higher the temperature, the higher the rate of solubility. Rate of stirring, the faster, the higher rate of stirring, the higher the rate of solubility. And finally, the size of solute. The smaller the size of solute, the smaller the size of the solute, like it's in a powder form, it will produce a bigger total surface area that is exposed to be dissolved in the solvent. So smaller size of solute, the bigger the rate of solubility. You can see here an example. If you want to mix a chocolate drink, you must have a hot water, and the chocolate powder must be in a very fine sugar and chocolate powder, and you have to stir it as fast as you can. So all these three factors will increase the rate of solubility. Increase the temperature, decrease the size of the solute, and increase the rate of stirring. Make it fast. And finally, we want to look at another liquid, which we call it a colloid. A colloid is formed when two or more solute form a mixture. When two or more solute form a mixture, and they will disperse evenly in a solvent. See, for example, coconut milk. You can't see the solutes, but it's dispersed evenly. It's like a complete mixture, but you realize it is not transparent. This is how a colloid look like. So finally, we see a colloid examples like whipping cream, ice cream, and shaving cream. These are examples. And finally, we have three types of solutions. A basic solution where it's even, transparent actually. Colloid, not forming a clear mixture, but there's no precipitate. Suspension, left out for a couple of minutes, you can see the precipitates at the bottom. Suspension, colloid, and a solution. Finally, we want to look at water. Water is known as a universal solvent. Why water is called a universal solvent? Because it can dissolve almost all the substance that we know around us. And it can easily dissolve fertilizer, it can dissolve medicines, and also it can dissolve all the detergents and soap. So water is known as a universal solvent because water is able to dissolve a lot of substances. Finally, we're going to look at organic solvents. These are solvents that will dissolve carbon base. They are carbon based. They can dissolve any substance that cannot dissolve in water. If let's say you have substances that cannot dissolve in water, you can use organic solvents to dissolve them. Example are alcohol, kerosene, acetone, turpentine, and ether. And each of these organic solvents are able to dissolve other organic substance. Perfume can dissolve in alcohol, antiseptics can dissolve in alcohol, paint can dissolve in alcohol, and iodine. If you look at kerosene, can dissolve oil, tar and rubber. If you look at acetone, can dissolve nail varnish, lacquer and lipstick. And turpentine can dissolve paint remover, paint thinner. And finally the ether can dissolve oil, fats and grease. So I repeat again, all these substances, perfume, antiseptic, paint, iodine, oil, tar, rubber, nail varnish, lacquer, lipstick, paint remover, paint thinner, oil, fats and grease, all these substances, they can't dissolve in water. So the best way to dissolve them is to dissolve them in an organic solvent such as alcohol for 4 of these, kerosene for 3 of these, acetone for 3 of these, turpentine for 2 of these, and ether for 3 of these. Thank you, students. I'll see you again in the next lesson. Bye.